Okay, so let's do together question number 3. Find the eigenvalues and eigenvectors of matrix A. This is matrix A. We know that the characteristic determinant is equal to 0. A minus lambda I is equal to 0. Okay, this is 6 minus lambda minus 6, 5, 14, negative 13 subtract lambda 10, 7, negative 6, 4 subtract lambda is equal to 0. This reduces to lambda cubed minus s1 lambda squared plus s2 lambda minus s3 is equal to 0. Okay, s1 is the sum of elements in the main diagonal. So it's 6 plus minus 13 plus 4. This is equal to 6 plus 4 is 10. Subtract 13. This is negative 5. S2 is equal to the sum of minus of elements in the main diagonal. So this is negative 13, 10, negative 6, 4 plus negative 13, 10, negative 6, 4 plus 6, 5, 7, 4 plus 6, negative 6, 14, negative 18. Okay, this is equal to, if you check this is 13 by 4. Okay, you can use your calculator. This is negative 13 by 4. Okay, negative 52. Subtract 60. Here the answer is 8 plus this is 24 subtract 35. 24 subtract 35. This is negative 11. This is 6 by negative 13. 6 by negative 13. Okay, negative 78. Subtract 6 into 14. Okay, this is 6. 8 plus 6, the answer is 14. Subtract 11, the answer is 3. S3 is nothing but the determinant of matrix A. Use your calculator to find the determinant of matrix A, which is equal to negative 1. Okay, the equation now is lambda cubed minus s1 is negative 3, so this becomes 3 lambda squared. Okay, plus 3 lambda minus plus 1 is equal to 0. Use your calculator to solve this equation. Lambda is equal to negative 1, negative 1, negative 1. Okay, repeated the root. We have the eigenvalues. So the eigenvalues are negative 1, negative 1, negative 1. We are now able to find the eigenvectors. Let's find the eigenvectors together. The characteristic equation A minus lambda I into x is equal to 0. This is 6 minus lambda minus 6, 5, 14 minus 18 minus lambda 10, 7 minus 6, 4 minus lambda. 4 minus lambda negative 18 subtract lambda 6 subtract lambda negative 6, 5, 10, 14, 7 negative 6 into x1, x2, x3 is equal to 0. 6 subtract lambda x1 subtract 6 x2 plus 5 x3 is equal to 0. This is 14 x1 negative 3 negative 13. Okay, negative 13. So this is plus negative 13 subtract lambda into x2. Okay, plus 10 x3 is equal to 0. Now this is 7 x1 subtract 6 x2 plus 4 minus lambda into x3 is equal to 0. Let's check here. Okay. 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 Now case number 1. Case number 1 is equations I. If lambda is equal to negative 1, equations I becomes, okay, equation I become what? 6 subtract 1, this is 7. Okay, so this is 7x1 subtract 6x2 plus 5x3 is equal to 0. This is 14x1 negative 13 subtract 1. So this is negative 13 plus 1. So it's negative 12 x2 plus 10 x3 is equal to 0. Last one becomes x1 minus 6x2 plus 4 subtract 1. This is 5x3 is equal to 0. If you reduce this equation, it becomes 7x1 negative 12x2 plus it's negative 6x2 plus 5x3 is equal to 0. If you check again, this is the same equation repeating itself. You take one equation, 7x1 minus 6x2 plus 5x3 is equal to 0. Okay, if you have one equation, assign that you assign one of the three variables a value. Okay, so I am going to assign 0 to the variable x1. Let x1 be equal to 0. This becomes negative 6x2 plus 5x3 is equal to 0. This is negative 6x2 is equal to negative 5x3. Divide both sides by negative is 6x2 is equal to 5x3. This is x2 by 5 is equal to x3 by 6. So the eigenvector x1 is equal to 0, 5, 6. 0, 5, 6. This is x1. Okay, case number 2. Okay, I'm not going to alter these equations. Okay, since again the eigenvalue is negative 1, so I'm going to say case number 2. If lambda is equal to negative 1, equation 1 becomes this one. Okay, in case number 1, I assign the 0 to the variable x1. Now I'm going to assign variable x2 to what? To 0. Okay, let x2 be equal to 0. The equation becomes 7x1 plus 5x3 is equal to 0. 7x1 is equal to negative 5x3. Okay, this is x1 by negative 5 is equal to x3 by 7. Okay, therefore x2 is equal to negative 507. Second eigenvector is negative 507. Let's find the third eigenvector. Case number 3. I'm not going to change again. Case number 3. I'm going to take one of the three equations, x1 subtract x2 plus 5x3 is equal to 0. Now I'm going to say let x3 be equal to 0. It becomes 7x1 subtract 6x2 is equal to 0. This is 7x1 is equal to 6x2. Okay, this is x1 by 6 is equal to x2 by 7. So the third eigenvector is equal to 670. Okay, the third eigenvector is equal to x3 is equal to 670. So these are the eigenvectors and these are the eigenvalues. Job done.